Hello students, I myself Naresh Bokhani on behalf of Sri Uttam Secondary English School, Anjar, managed by Anjar Education Society, going to present this video for second part of chapter 10, Light. The remaining part of this chapter covers the topics image, mirrors and its types, a ray diagram of mirrors, uses of mirrors, and sign convention and mirror formula. So students, previously we have learnt there what is light, property of light, law of reflection, and ray diagram rules, about the concave mirror and image is created by the concave mirror. So now in this second part we are going to understand about the convex mirror and image is created by the ray diagram rules and uses of this mirror. So see, the image formation by convex mirror, second type of curved mirror. Here also some rules we have to follow to get image. So first rule, a ray of light incidence on surface, you may say outer curved surface, which is a reflecting surface, and after reflecting rays bouncing back. So in this case a ray of light parallel to the principal axis of a convex mirror appear to diverge from the focal point. It means when ray incidence on a surface at an incidence point, from that point it reflecting there, and after bouncing back from that point, if we extend the ray backside of the mirror, so it passes through F and it appear coming from focal point. So in this case image is produced where two rays going to appear to meet. One ray passing through center of the curvature C. If we consider at this point as a normal, so two angles are formed there, one angle incidence and the other angle of reflecting. So two rays considered here, one coming parallel to principal axis and after reflecting it diverges from that point, and one ray we have to consider passing through center of the curvature. So this is considered as a normal, and the ray which bouncing back, it makes angle with this normal as a reflected angle, and ray parallel to principal axis makes angle incidence. Then see, in this screen here ray of light which is directed towards the principal focus of a convex mirror after reflection will emerge parallel to the principal axis. Here about this convex mirror, the first screen you can see outer surface is smooth you may say reflecting surface, and inward surface, rough surface, we may say hard surface. And focal length from the point P to F and center of the curvature will be double of focus, so it will be 2F. So a ray which directed toward the principal focus, in this case of convex mirror, after getting reflection it emerges parallel to the principal axis. So the previously, as we have seen, something here, a reverse process going. Then third rule, a ray of light directed in the direction of the center of the curvature of a convex mirror is reflected back along the same path. Here the incident ray fall on the mirror along the normal to the reflecting surface, as you can see here below the text, image point forming there after reflecting the ray of light coming from object. So object point is left side of this convex mirror, and ray of light coming, one ray we have to consider which passing through center of the curvature, and it will be the normal. It means you have to imagine that then a ray which bouncing back and enters in our eye. So two angles are forming there and both are equal angles. This follows the law of reflection, and this bouncing back ray, if we extend it passing through a point on principal axis, that is the image point. Now ray of light incident obliquely, not parallelly but obliquely, a point P is reflected obliquely. So in this case a ray coming from source of light incidence at a point P forming angle I, you may say incidence angle. After reflecting it forms angle R, reflected angle. So incidence angle and reflected angle both are equal and follows law of reflection. So here the incident and reflected rays follows the law of reflection at the point of incidence P, making equal angles with the principal X. Smaller than object but behind the mirror. Next, see, different types of images are there, and due to the different images, in the case of the convex mirror, how can we using this? So convex mirrors are commonly used as a rear view, you may say wing mirrors in vehicles to facilitate safe driving, because they always give an erect though diminished image, and you already experienced this thing that when driver driving the vehicle, so backside, any vehicle coming from backside, so driver can see, you may say view, the wide and long distance area through this type of convex mirror, and he can make himself safe driving. No doubt images are small one, but driver can understand there some vehicles coming from backside, and he can make himself safe. Due to this curve outward, they have a wider field of view. So another use of this convex mirror is there, that it is outward curved, and reflecting rays are diverging, so it covers a wider area, large area. So visible area with the help of this convex mirror is wider field of view, and that is why convex mirrors are used. In this case, convex mirrors enable the driver to view much larger area than would be possible with a plane mirror. Obviously, you can say in a plane mirror, a fixed area, whatever rays are incidence on this area, that rays only reflecting area, and image can be seen there. But here outward curve covers large area than the plane mirror. So in this case it is useful to cover larger area than plane mirror. Convex mirrors are used in offices and shops for security also. And students, you are very much familiar with this thing. In offices, shops, railway station, and nowadays on a road also in cities we are finding some cameras, so they covers area near about maximum area they covers and whatever incidents may be happening there, so we can see with the help of this. And that is why convex mirrors are used in different places for safety and to know the movement near about these places. It is also used for traffic control. So as we have told, on road these convex mirrors are used to control the traffic, and in this way convex mirrors are used. Now see the sign convention for a reflection by spherical mirrors. So students, you have to understand here, whatever ray diagrams rules we are following, so where we are keeping the object, at what distance we are placing the object, and where image we are getting, that you understood in the both case of concave and convex mirror. But if we want to find the measurement, so how can we measure the distance of object and images, that you have to understand by new sign convention. You may say Cartesian sign convention. So here are also some rules you have to keep in mind. So see, first of all, the distance is measured from point P, both side, left side and right side. It means the where we have kept the object is object distance we can measure from the point P to object, and image wherever formed there we can measure the image distance from point P pole to the point of image. So the object is always placed to the left to get the image, because the reflecting surface should be in front of the object. So mirror, that means light from the object falls on the mirror from the left hand side only, and that's why object is always placed to the left of the mirror. All the distances parallel to the principal axis are measured from the pole, you may say point P, and measures to the right of the origin are taken as positive in sign, while those are the left to the origin are taken as negative in sign. You may say positive and negative, two types of distances you have to measure when you are measuring from point P, you may say origin, to right side. That will be taken as positive because the ray coming from the object or source of light, its direction is from left to right, so we are measuring in that direction will be positive distance, and while the left of the origin means we have to measure the distance opposite direction of incidence ray, so that will be negative. So here in this screen you can understand, as a origin taken O, so from O to right side all distances are positive distance, and from O to left all distances are negative distance. So in this case we have to follow new Cartesian sign convention. Distance measured along y-axis above is taken as positive, while along y-axis below is taken as negative. So here also you have to keep in mind that the object, if you consider here as a x-axis and y-axis in graph, so from origin upside from up to y, along with y, the object whatever we are measuring, it will be positive, and below the origin to the y dash side, you may say along with y dash side in graph, that will be negative. So regarding this case also you can keep in mind. So we have to measure the object which is vertically, you may say erect there, sorry, not vertically, but you may say erect there, it will be positive, and inverted, you may say downside, that will be the negative. So in this case we have to keep in mind this sign convention rules. Now students, you see mirror formula and magnification. So what do you mean by this mirror formula? So whatever images are formed there, the distance of image, the distance of object, and length of focus point from point P, you may say focal length. So this formula gives the relation between these terms, and with the help of this we can find image distance, object distance, and focal length. Here see mirror formula, you have to remember and keep in mind 1 upon V plus 1 upon U is equal to 1 upon F. This formula you have to use, and regarding the terms where V is for image distance and U for object distance, F you know focal length. So there is a relationship between these three quantities given above in this formula, and we can use this formula taking values of these terms. Out of 3, 2 values should be there to find third one. So in this case we can calculate and find the remaining quantity whatever we want to find. Now magnification, how many times the image will be larger or smaller, that we can understand with the help of this magnification. So it is the ratio of the height of the image to the height of object. If h is the height of the object and h dash is the height of the image, then the magnification m produced by a spherical mirror is given by the formula small m is equal to height of the image, you may say h dash, divided by the height of the object, say h. That means small m is equal to h dash upon h. This will be the formula for the magnification. The magnification m is also related to the object distance u and image distance v, as m is equal to h dash upon h, and we can also write here, because h dash is the image showing here, image height of image, so related to this we can write v, and h showing height of object, so we can write here u, and this will be the negative sign minus v upon u, because the magnification m is also related to the object distance u and image distance v. And you know, as per sign new sign Cartesian sign convention rules, we have to measure the object distance opposite to incidence ray, you may say from pole point to left side. So obviously it will be minus. Now the height of the image should be taken as positive for virtual image. Students, you have to keep in mind the height of the image, it should be positive for virtual image. However, it is to be taken as negative for real images, and a positive sign in the value of the magnification indicates that the image is virtual. If positive sign we are getting after calculating in this formula, so image will be